heat 1. So as the instructions say here, write the givens, write the equation, write the numbers in the equation, put a box around your answer. So there are 4 X's on this. You can get just a blank piece of paper and number it number 1 and show all your work there, and then take a picture of that and either send it to me through Google Classroom, or you can send it to me on Remind or email it to me. One of those will work. So the first step is write the givens. Q, M, C, delta T. Q, according to your notes, is the amount of heat. That's going to be in joules. M is the mass in grams. C is a specific heat with a really weird unit of measurement, joule over gram degrees Celsius. And delta T actually means the T, and I'm going to say T larger minus T smaller, or T final minus T initial. If T final, it actually ends up getting colder, then you want always T larger minus T smaller, so that your temperature is not going to be in a negative number. So Q is equal to MC delta T. So we write the givens, we write our equation. Q equals MC times delta T. So our Q, so how much heat? How much heat? That's Q. So here, how much heat? That means that's what we're going to be looking for here. Must be added to 124 grams of brass. So we've got 124 grams of brass. C for brass is 0.376. 0.376 joule over gram degrees Celsius at 12.5 degrees to raise the temperature to 97 degrees. So we've got T larger minus T smaller, so 97.0 degrees minus 12.5 degrees. And that should be 84.5 degrees. So our delta T, the change in temperature, is 84.5 degrees Celsius. We keep our temperature in Celsius because remember that the units for C include Celsius, so we have to be consistent with our units. So we're looking, here I gave you a hint here, we're looking for Q. So Q equals the mass, 124 grams, times 0.376 joule over gram degrees Celsius, times the change in temperature, 84.5 degrees Celsius. Okay, I put parentheses around everything because it helps me to separate them out and say, hey, this is a number, this is a number, this is a number, or this is a measurement, this is a measurement. I just keep them separate. It makes me happy to do that. You don't have to, but it makes you aware that they're each individual entities. I would not put those parentheses in my calculator when I did this. What I want to point out now is look and see what units of measurement cancel. I have a gram. Remember, we can put this over 1, right? I have a gram on top of a fraction, a gram on bottom, so they cancel. I have degrees Celsius on bottom of a fraction, degrees Celsius on top, so they cancel. The only unit left over is the joule, and that's exactly what it's measured in. So when I pop it into my calculator, I have 124 times 0.376 times 84.5, and I get 3,939.728 joules. So Q is equal to 39.728 joules. Okay, so here's my answer. Now before we go on from that, a lot of times instead of measuring things in joules, we measure them in kilojoules. Kilojoules is really pretty common, and a kilojoule is 1,000 joules. So if I want to change this from joules to kilojoules, well, I would do my dimensional analysis, 3939.728 joules times there are 1,000 joules in 1 kilojoule. So that basically means I'm going to divide by 1,000. That would be 3.9397. So in this case, it'd be 3.940 kilojoules. So a lot of times, you don't have to do this, but I'm just pointing this out to you because a lot of times you'll see them in kilojoules. In many cases, instead of in joules, they'll put it in kilojoules. So it can be both in that case. Now, we want to do our calculations in joules because, again, C, that specific heat constant, is always going to be measured in joules. So it's joule over gram degrees Celsius. So just pay attention to your unit of measurement when you do this. Number 2 is set up the exact same way. Pause this and do that. So you're going to do number 2. I'm going to look at number 3 next. Pause this and go do number 2. So I'm going to drop down to number 3 and write the givens, write the equation, numbers in the equation, draw a box around your answer. So I have Q, M, C, delta T. A 500 gram block. You can go through and circle your numbers here. I can go through and all I'm going to do is I'm going to circle the number. So I've got a 500 gram block. That's obviously going to be mass. I have 5,016 joules. Well, that's not a mass. It's not a specific heat. It's not a temperature. It's Q. That is, they've given us Q. So we have 5,016 joules. And then it's got a temperature changes from 20 to 30. So we have delta T is 10 degrees Celsius. And it says calculate the specific heat. So we want to find C. So our equation is Q equals MC delta T. I personally prefer to rearrange the equation so that I don't have numbers and crap all in there messing things up, making it more messy. So I'm going to rearrange my equation right here. And when I do this, I want C, so I'm going to leave C where it is. These 3 things are multiplied. So in order to get them on the other side of the equal sign, I do the opposite. Opposite of multiplication is division, so I'm going to divide by M, and I'm going to divide by delta T. The M and the delta T cancel out. If I do it to one side of the equation, I have to do it to the other, so I have M delta T divided out over here. So my equation becomes Q divided by M delta T equals C. If you don't like that, then you plug all your numbers in there and then you solve for the unknown. C in this case is your X. Solve for X. I've rearranged it because I like to do it that way. So now I'm going to plug my numbers in. 5,016 joules divided by 500 grams times 10 degrees Celsius. And look, are there any units of measurement that cancel out? No, there are not. So everything's in there. Joule on top, gram, degrees Celsius. And lo and behold, isn't that the unit of measurement for C? Joule divided by gram times degrees Celsius. Now, when I put this in my calculator, I'm going to put one set of parentheses in green right here. I'm writing them in green. Those are the only parentheses that I'm going to put in here. Equals C. So I'm going to put 5,016 divided by open parentheses 500 times 10 close parentheses. So it looks like this in my calculator, if you can see that. There you go. So plug that into your calculator and put a box around your answer. Number 4 is going to be set up very similarly. It's not the exact same thing because in this case, in number 4, they want you to find mass, M, instead of delta, instead of the C. And then I'd like you to look at number 5. So when I look at number 5, pause this, do number 4, and then we're ready to go on to number 5. So on number 5, if you're not pausing this and doing your work there, you're really wasting the video here. So pause this, and then you can go back and do number 5. So I've got Q, M, C, delta T. All right, if 1420, I'm going to go through and circle the numbers. Ooh, look at that. And what will be the final temp? Okay, so I've got Q is 1420 joules. They're added to a 100 gram block of carbon, so my mass is 100 grams. And C is 0.71 joule over gram degrees Celsius. And, so if 1420 joules of heat are added to a 100 gram block of carbon that starts at negative 20 degrees Celsius, what will the final temperature of the carbon be? Okay, so we have T final minus T initial. That's what delta T is. So T final and T initial. Since they're not having me do just delta T by itself, which by the way is number 6, I have to split these up. T final, what will be the final temperature is what they're asking me for. They gave me the starting temperature of negative 20. Okay, so write my equation. Q equals MC, and instead of writing delta T, I'm going to write T final minus T initial. Now I'm going to plug my numbers in. But again, I like to rearrange my equation to make it simpler, and so what I'm going to do is notice the m and the c are multiplied by that delta t here. Remember, this is just delta t right here. So I'm going to divide out mc on both sides. That cancels it out. So my equation is q divided by mc equals t final minus t initial. Stay with me on this. Now I'm going to plug the numbers in. So q is 1420. M is 100 grams. And then C is that ugly number, 0.71 joule over gram degrees Celsius. And look and see what cancels. I have a joule on top and here, on top and bottom here, so they cancel. And then so far nothing else cancels just yet. So then what I'm going to do is I'm going to say, wait a minute, I do have something else that cancels. I've got a gram on bottom and a gram on top here, so those cancel. Oh, look, that means all I've got left is the degrees Celsius. Isn't that what they're asking me to find? What temperature? Now on the other side, I have T final, which is my x, minus, and my T initial is negative 20 degrees Celsius, right? If I have a minus and negative, what does that do? Doesn't it make them both positive? Yeah? Okay, I'm going to do the numbers over here on this side first. So I have 1420 divided by, open parentheses, 100 times 0.71, close parentheses. And I've got, oh, look at that, it's 20. So 20. And the only unit of measurement I have left here is the degrees Celsius, equals T final plus 20 degrees Celsius. How do I get, here's my x, right? How do I get this? Well, this is added over here, so now I need to subtract it. What is this? 0 degrees Celsius equals T final. Is 0 degrees Celsius a viable temperature? Why, yes. Yes, it is. There's your answer on this one. Number 6 is not so difficult as this because they don't want you to find T final or T initial. They want you to, I'm sorry, well, crap, I don't know which one it is. It's not that hard at all. So anyway, that was the toughest one. All right, you've got 3 of them left to do. Get those in and give me a picture and send it to me.